be releasing this piece of software here and to get the chance to show it to you all. So if you've been following the chat, you already know we have this set up as a webinar, so you're perfectly welcome to drop any questions that you have as we go through in the chat. I can answer them, or one of my colleagues here, Connor McCalla or Jason Reed, are happy to also answer questions in the chat. Love to hear your feedback as we go along, and I'll monitor it to answer anything as it happens. Just quick check, you all give me a little a thumbs up in the chat. You can see the video, the sound's working okay for everyone. Just another little piece of housekeeping, we are recording the meeting, so we'll send that out afterwards. You can go back and rewatch things if you want to afterwards. Okay, sounds good. Good to hear it. Okay, so before we get started and get into the actual software, we've actually been spending a couple years now building what we call this data decision workflow. And we've worked with operators in every major shale play in the Western Hemisphere, from the Montney down to the Vaca Muerta and everything in between. And we've kind of learned that there are a couple different things that really keep companies from being successful at using the vast volumes of data that have been generated within the unconventional space in order to make ultimately better decisions for their assets and for their businesses. And really the pain points that people run into first is that it takes a lot of time and effort to build analytics ready data sets. And as one of our board members told us recently, data science is 80% data and 20% science. And it really, it takes a lot of time, effort, and customization to get those ready. So that's number one. Second big item is that it can be really difficult to code and then to maintain the code if you actually have it, machine learning or other statistical algorithms. We get calls all the time from operators or investors who had the capability to run a machine learning forecast, but the only guy who knew how to run it just left, and now they're staring at pages and pages of code, and nobody has any idea how to run it. And it really is a pain. It's a software problem, and it requires software engineers to solve it. And then finally, number three is lack of transparency in the model forecasts. Y'all have all probably, if you've done any practicing of machine learning yourself or data science, you can have a super accurate forecast, but if you don't understand why the model is coming up with its forecast, then it's going to be tough to get buy-in from key stakeholders, from management, from reservoir engineers, et cetera. So that's what kind of we learned. And so we've really built out a full platform that allows companies to be successful in implementing machine learning in a short amount of time to get to very accurate answers, ultimately to make these decisions over there that you see on the right. Now, our platform has three components. There's data engine, model engine, and forecast engine. Each of these are independent web-based software tools that our customers use to build data sets, build models, and build forecasts. We've spent the past 2 years building our cloud platform. It's taken a team of, actually at this point now we're 30 employees. So that's software engineers, data scientists, reservoir engineers on the customer delivery side, and plus some sales marketing staff, overhead like me. But it's been a lot of effort to put it together. And just the past few weeks, we've released Model Engine, which is the middle of it. It's the heart of it all. And that's where the models are actually trained that will try to predict what an oil development, that's an individual well or a full unit, will produce. That could be for your upcoming drill schedule. It could be you're wondering what to do for your spacing or stacking for a given unit. It could be for completions optimization. At its core is forecasting, and learning what drives performance from the training data that you have from any given basin or multiple basins that you're interested in. So that's what happens in Model Engine. I'm going to give you, since it's a totally interconnected platform, I am going to focus on Model Engine today, but I'll give you a very brief introduction into Data Engine and Forecast Engine. Also, I want to be respectful of everyone's time here. So we have 30 minutes scheduled for you today. We're always happy to do more time to follow up. So it is going to be a high level overview. Please drop questions in the chat as they come up. Okay, so I've hopped over to our web-based software here over on the left. We have these three main applications: data engine, model engine, and forecast engine. You see they're all just little icons popping up on the screen there. And each of these would be something that you'd be licensed to as a customer of Novi, or our customers are licensed to right now. I'm going to click on data engine, which is really what's used to build the analytics ready data sets. There's a lot of detail that goes into building these data sets for oil and gas. Ultimately, what we want is a summary of all of the relevant information about an individual well so that we can train a model to learn how that data impacts the performance. So that's going to be things like header information, production data, directional surveys, subsurface, that will then join and blend together in order to form a clean data set. So you may have different units, different data sources, there are transformations. We'll need to calculate spacing, we'll need to join the subsurface to the well locations. Really, there's a lot that can go into that. I'll bring up just a simple example to show you at a high level what it's doing. This is one of our header collections, which you can use to merge together different data sources. So here I have 5 different header sources that I've uploaded, or a colleague of mine has uploaded here at the source level. So we have things like this could be your own data, it could be some public data, maybe some of this you can get from directional surveys. If you wanted to add in another source, let's say you had a bunch of proprietary completions data, let's say that your completions engineers gave to you or you traded for, you just hit the add button and it drops it in as a source. And then you can move that up and down. So you say, yeah, I trust this thing second most after my own data. And so what our software will do is it'll intelligently blend together these sources based on the confidence that you've specified here. So it's doing that. It's also cleaning the data. It's normalizing the units, aliasing things. There's a lot going on behind the scenes here, but the end goal is to get you a really high quality data set that goes into your model. So there's really no way to talk about modeling without talking about data sets. So I just wanted to give you that very high level overview there, introducing the tool. So next I'm going to go into model engine, which is maybe the fun part, I don't know, but this is where we train a model that learns from the input data set. So you have a couple options of, log me out, security. Give me 1 second here, y'all. So when you're building a model, you have a couple things that you need to keep in mind. The first is what wells are you going to provide to the model? And the second is what training variables are you going to use to predict it? So let me go ahead and get my login right here. So model engine allows you to take those input data from data engine, get it ready to go into a model, train the model, configure all the features, the parameters, all that, so that it can actually get you your production forecasts and be used for optimization exercises, quarterly forecasting, investment decisions, all that type of stuff. So there's 2 steps to building a model here within model engine. The first is the model input phase. And this is, you take in a data set that you just built in data engine. So let me call this one Demo Delaware here. I'm going to hit the next button. So here I see all the different data sets that we've built in the Permian and some other basins here. So I'm going to choose this public-private merge that we built. It has 19,000 wells. It has oil, gas, and water production. I'm going to hit the next button there. And then I'm going to define rules that filter which wells go into the model. And in our experience, this is actually one of the most important pieces of building a model, is restricting the data that you want to go into it. So you can imagine that you could build a data set that has all the wells in the Permian, but it may not actually be relevant to include, let's say if you're doing a Midland Basin model, you may not want to be including Woodford wells that were drilled on the fringe of the Central Basin platform, or other type of wells like that are really not relevant whatsoever to what you're interested in for your activities. So you can go in and for instance, filter this down to certain formations. So I'm in the Delaware, I'll go grab my, I want a couple of the Wolfcamp zones. Maybe I don't care about the Wolfcamp D, but I do care about the XY. Maybe I want to get in a few Bone Springs zones there for my modeling. But this is very easy to do that type of filtering there. So I can do that filtering. Maybe I want to exclude wells that had very tiny proppant intensities from a long time ago. May not be super relevant to the designs that are being done today. So Commonly, I'd want to say something like 100, between 100 and 3,000 pounds per foot or something like that. So this is all going to be part of the experimentation that you do when you're building a model. It's an iterative process. And the truth is that there's no universal playbook or algorithm that can make something which is accurate for every single basis, for every single use case, for every single data set that you have access to. And so really what we have wanted to do here with Model Engine and the rest of our platform is to give you the self-service tools to go through everything without needing to do any coding. So based on the filtering rules that I have here, which has that information plus some other basics, like the well needs to have lateral length, that a well needs to have some production, I have a result of 9,715 wells that would be included in my model input file. So that's step one. And it's a very kind of common part of our workflow. You build that model input file. If you wanted to try a couple different of these, let's say you wanted to mix up the rules, demo Delaware, and you just wanted to do, let's say, Reeves County or something like that, you can just copy it and go through and change the rules. So it's very easy to copy, replace, edit things that way, so that you can kick off a bunch of experiments in a short period of time. That really helps shorten that cycle time to get through and run things. So that's step one, which is building the model input file. Step two is actually building the model itself. So I'm going to go hit the create button here. We'll call this one Demo Delaware again. And for this, I have two options up at the top level, and that's, do I want to build a pre-drill forecasting or PDP forecasting model? So we use different algorithms for those. There's some similarity, but there's some important differences. And then there's also some slight differences in the options that you have to configure. I'm going to choose a pre-drill forecasting model for today. But it would look very similar if you're choosing a PDP forecasting. So first thing I do is I choose a model input file. So I'll go grab that Delaware one that we ran. Has 6,798 wells in it. I'll hit the next button here. So then I get to the features page. And this is, and if you're not familiar with data science or machine learning, features is basically another way of saying variables. And really this is, what's the model going to be learning from to see what drives production. And so you may have a data set, you may have 100 or 1,000 different features that you've built into your data set. You can have all sorts of different subsurface, you can have all sorts of different spacing, there can be 100 different ways to describe the spacing of a well, got a bunch of different completions. You probably don't want to use all of those for your model. Your model is going to learn from a smaller set of highly accurate features that are going to give it the most predictive results ultimately. And so you want to filter it down to a subset. And one way to think of this, filtering to make the model input files, like filtering the rows that go into the model. And this is like filtering the columns. So that's a typical way that we'll introduce this to new customers or people who aren't used to data science. But because we have all those different variables that can pop up here, we do have the ability to filter. So you can type in a filter, and let's say I want to filter to proppant, or you can put in a filter up here by using the drop down to filter to certain categories. So I'm probably going to want to choose fluid and proppant, formation, lateral length, TVD. Those are very common things that our customers will use when they're building a model. I'll go grab some different geologic features here now. So gross thickness. Maybe I'll go grab permeability times height, porosity. These are subsurface grids that we have as part of our data offering. So if you license our data, we also have basin-wide subsurface attributes. In the Delaware, I think we have 1,400 control points of petrophysical wells that have gone into that interpretation. So very high resolution, accurate regional grids, very, very helpful for this type of an exercise. Of course, you can use your own as well, and most of our customers do have their own subsurface. Then I'll go grab, let's say, some spacing features. We calculate these spacing features based on the data set that you've provided up at the very beginning in Data Engine. So you can upload directional surveys, headers that have surface hole and bottom holes, and we'll calculate the spacing off of those. So these are all spacing features that we've calculated. So you may want to calculate, say, the number of wells that are in a radius around the well of interest. In the Permian, we found that can be pretty useful because a lot of times it's not just how close the next closest neighbor is. You probably have significant communication going on across your zones. even if that's, that's not the case in a place like the Bakken, let's say, just to choose a different one. So I'll go grab whatever. I'll just go grab and highlight a bunch of different other spacing features there. So you see over here on the right, I've got 23 different features that I passed over to the model. I may want to actually use the model to help me narrow that down further. So if I hit this use the model to select the most predictive features button, it'll give me a little dialogue that I can use to do feature selection. The way that this works is that the model will try different subsets of the features and see how each subset, each permutation impacts the error score of the model. So essentially, it's a way of algorithmically choosing a more accurate set of features to use for your forecast. So I'll choose, let's say 12 features right there. I know I want to include fluid, proppant, formation, and lateral length, let's say. So I hit the override button, and in that way, it won't ever drop those features. So those are going to be present in every permutation that the algorithm runs. Whereas it's going to drop 11 of the remaining and keep 8 of the remaining after those 4. So this is typical, typical data science workflow. Very nice to be able to have the algorithm kind of run that for you automatically. You not have to configure it. It will take significant amount of time compared to not running feature selection, because it is training so many different permutations. So maybe once you get into a set of features that you like, you'll turn that off. But it's, your models are still going to train pretty quickly because they're going with a cloud compute there. Did it rank the features? Yeah, Jorge, I'll show you an example of that here at the end. After I kick this off, it can give you feature importance as well. Yep. So next up, we go to the parameters screen. So this is, you configure some of the different options for the model. First off, you can set the production that the model will be predicting. I can say I want to predict oil, gas, and water. Maybe you don't have very much water data and you don't want to bother training a model for that. You also have the option to normalize the production by lateral length. And in that case, the models would be forecasting barrels per foot, MCF per foot, meters cubed per meter. But it'll transform all its forecasts back into the absolute barrels or absolute MCF space, but it can get a more accurate result by normalizing lateral length there. But that's an option you have. You may not want to use that all the time. Next up, you have the training interval, and this is the data that the model sees when it's going to train. And for pre-drill, it would also be the interval that it's forecasting. So it'll start at day 30, and it'll go out to day 90, 1080, 2160, 1800. You have the option to configure that. You probably don't want to go all the way out to the max. Your data may not be super great there. But you can go. You set that to what you want. So for pre-drill, normally we'd recommend something like 1080, 3 years. Depending on your data set, if you're in the Vaca Muerta, maybe you want to go a little bit younger. If you're in Bakken or the Barnett, you can go a little bit older. But that's just kind of a question for you. AJ, you had a question as to whether or not we're using the tree model or a ridge regression. I'm not actually positive whether or not we're using the same tree regressor that we're using for our native algorithms for the feature selection. I'll have to go ask one of our data scientists and check on that, but it's a good question. So that's the training interval there. Next up, we have the test group definition, and this is really an important part of the workflow. And this is how you actually set up your test group or your evaluation group. And it's really important to actually understand how the models are performing, of course, in order to build trust in them. And so the typical method is that you take, you have all your data to start with, and you take some portion of it and you put it to the side, you train it on the training data, and then you use that model to forecast or predict the holdout data. So that's the typical workflow this takes. We've customized that a little bit for oil and gas. We have a few different options here. One is a random 20% of paths. So one thing you might run into if you're doing this yourself is that if you split randomly by the unique key or the API, you may get some wells on a pad in the training set and other wells on the pad in the test set. And that can give you an inaccurate or an unrealistic view of how accurate the model is, because in the real world, you're not going to have that ever happen. It would be great. I'm sure you could get accurate forecasts on the wells that are coming in second after the first group, but so we don't. So we'll split it by the pads. The second option here is a time-based cutoff. So sometimes we call this a time machine, and this is a way of going back to a certain date in the past. What the model will do is it will cut off all of the data from after that date, and withhold it. And it'll train the model on the data from before that date. In this case, it's also withholding all of the production data. It's not just saying when a well came online, it's actually withholding all the production data. So it's not, it's sneaking in a well a little bit early. But let's say I want to go back to August 1st and see how it's done on the last 6 months of production. That's something that I can configure, and it'll run automatically for me there. So that's a very common thing that our customers will use as well. You also have the option to do a custom feature. So if you just want to define your own test train split for whatever reason, you can choose a custom feature and define test and train and go that way. So that's up to you. I'll stick with the random 20% of pads. Finally, I hit the next button and then I get to the review page. So now I'll have the ability to just kind of review everything that I put into it. If I wanted to add in someone else's email on here, I could say, send Connor an email whenever it's done, in addition to sending it to myself, but that's just something that you have the option for. So this is all web-based software, but once I build that model, it's going to go and spin up a bunch of different cloud compute instances to go and do all of the hard work of training a model. So model hyperparameterization, feature selection, training, evaluation, generating of model artifacts, like things like feature importance, like Jorge asked about, Shapley values, forecast for all those wells, and the exports into the cloud. So there's a lot of different steps that are being run, plus some of our little automated QA checks just to make sure that everything's running okay. So we did have a question about the ranking of the features. So I just want to show you a quick, one of the quick things that we generate. This is a feature importance chart that we're generating off of what are called Shapley values. And Shapley values are a really powerful tool to show you what's driving the production or the prediction. In this case, it's production. We're predicting production. So, but anyway, so they're a very powerful explainability tool within the machine learning community, not just within oil and gas. And what we have here is each of these different rows is a different feature that went into the model. And on the x-axis, we're showing you how much it impacted the prediction. Actually, that one's in, that's actually in a percentage right there. Looks like I don't have my formatting option there, but that's 5%, 15%, 25, 35%. And what that represents is how much each of these different variables push the prediction above or below the average of the training data. And so to summarize it in lay terms, the wider the spread here, the more of an impact it had in the aggregate. And the red or the blue, it indicates whether it's a positive or a negative correlation with the prediction. So here, for instance, I've got, this is the distance of the closest staggered neighbors. So it's kind of the further away the closer they are together, the shorter the distance, the lower the prediction is going to be. Et cetera. So if I scroll up to the part, I've got like the depth, the clay volume, the staggered distance, the fluid intensity, the distance to the parent. So you see if the parent's farther away, it'll have higher production than if it's drilled very close to the parent, all that type of stuff. So that's one of our main explainability tools that we work with. You can also look at those in kind of cross plot. So if I pull up, let's say that parent distance item that I was just talking about here, you can see that the further away the parents are, the more that bumps the production in the eyes of the model, and the closer and closer they get together, that more that degrades the production in the eyes of the model. So this is very powerful for understanding what the model has learned, for seeing into the model to figure out what's going on. So that's model engine right there. There's obviously a lot of other stuff you can get into. You can evaluate error scores. You can do lots of things, but ultimately you'll want to go and run some forecasts. So That's where you go into Forecast Engine, and that's not the focus of today. We only have a few minutes left here, but this basically allows you to use the models that you built in order to get forecasts for your upcoming drill schedule, for spacing optimization, completions optimization, whatever you're interested in, for your typical day-to-day business workflows. Yeah, and in the Sharknado, we do have each of these is an individual point in these dependent spots. Each of these individual points is an individual well. And what we've done for the Sharknado is kind of summarize that at a top level. So it's within each of these pie charts, we're showing you it's summarizing a bunch of wells. So this Sharknado isn't doing individual wells. It can go down to the individual well level. But in order to get it to look good, we have to do some summarization there. But when you go to things like a dependence plot, we do have individual well level statistics that are so every dot would represent a well. But it's a good question. So Forecast Engine, you go to actually leverage those models. And this has some advantages in being part of the same platform as Model Engine and Forecast Engine. So for instance, if I pull up this scenario of a bunch of Wolfcamp A's in Reeves County at 660 spacing, I've kind of laid out some different pads here using our little inventory tool here. And we've gone through and extracted out TVDs. We'll calculate subsurface, we'll calculate spacing, using all the same rules that you had in Data Engine and Model Engine. So you can go through and run and get individual forecasts for each of these different well locations that I've laid out across the inventory or across the acreage position that I put in here. So we don't have time to go into too much of this, but we do generate all those same kind of interesting data sets for that. So we'll show you MPVs, cash flows, forecasts for different scenarios, production drivers, analog wells. Lots of different powerful data sets that you'll get for any time you actually make a forecast. So that transparency is extremely important for us as well. Okay, so we're nearing the end of our time commitment here. Thanks for sticking with me on that whirlwind demo of our software. I'm going to take a couple of questions that people have already asked. Feel free to put more in the chat as we go, and then I can stick around for a few extra minutes. But first, we have a question from Ryan Campbell. He asked, does Forecast Engine forecast beyond what the model predicts? Yes, it does. What we'll do is actually, we'll go out, we'll use machine learning for a certain number of days. So that could be 3 years, and we'll extend that out, or 5 or 1. And we'll extend that out using a modified ARPS in order to get to an EUR. So I have a nice little graphic to show you how that's working here. But it is a very good question. So if we're working with pre-drill here, you'll have your machine learning predictions. And so that would be 1 year, 3 year, 5 years, whatever you set. So then we'll do a hyperbolic fit based on, you can specify the bounds of the B factors that we should look for, but we'll basically fit a hyperbolic to those machine learning predictions. And then we'll transition that over to a terminal decline at whatever specified percentage that you have there. 3%, 10%, whatever you use. So we want to make sure that we have something that's consistent. And of course, if you want to get cash flows, you want to get an EUR, you'll need that type of stuff. So yes, absolutely. Okay, so then we have a question from Aaron Powell. He asked, does the model care what type of data is loaded in? Could it be for something other than wells? We're pretty flexible in terms of the data that the model takes in, but we are focused on wells. So we're not going to forecast like a pipeline production, or we're not going to forecast the reliability of your rod pump or that type of stuff. So we are focused on forecasting well level production, but in terms of what you load in about the well, that's very flexible. So that's flexible there. Okay, so next we have a question from Samuel Schoon. Is any model optimization exposed to the user? So model architecture, hyperparameter tuning, etc. We don't expose very much of that. We will, we'll show you the error scores. We're not gonna show like individual cross validation scoring or individual hyperparameter scoring. If you are super interested in that, we do have all that stuff recorded in our back end, and we can share that with you. But for most of our customers, that's too detailed. but it's a good question. Okay, Bob Lamont asked, have you applied your model to conventional production, so heavy oil, et cetera? We are specialized for horizontal developments. So if it's a horizontal development, we can work with it. Our focus has been on unconventionals. Eventually, we probably will get around to other play types, vertical wells, et cetera. But for now, we've been focused on the unconventional. So it's a good question. Okay, so next we have a question from AJ about guiding the user away from overfitting. Yeah, that's certainly with great power comes great responsibility, I guess. We put our customers through extensive training during any onboarding. And so what we'll do is walk them through each step of the way. For instance, maybe the user has a feature in their model that's something like 1 year cum. You could include that as a feature and you'd get very good results, but it would be not ideal. We have put in some guardrails in some places, like you saw, for instance, we have that pad level split for pre-drill. We don't actually allow production features to be used as training, but there are still some ways to do some overfitting, but that's just part of our onboarding with any customers. I mean, we do have an extensive help section as well. But yeah, it's another great question. Okay, Jorge has a question. If you feed the forecast model to be drilled wells with location linked proppant, will the model predict the expected production curve? Yeah, absolutely. That's a great question. And yeah, I should have shown this. But so here, for instance, I have some forecasts for the Permian. So this is something that I was showing you. And for these pads, in this case, I have co-developed Wolfcamp A and Wolfcamp B that we've run here. So we have our P50 forecast there for each of these wells. I'm showing it in cube space for the Wolfcamp A and for the Wolfcamp B. I have those at different completions intensities, small, medium, and large. And then you see the P90 and the P10 for those. So we're in some kind of fringy acreage over here on the western side of Reeves County. So that's why you see a pretty wide spread. If we were closer to the kind of play core, you'd see a narrower spread. And that'll kind of change depending on the spacing that you're looking at as well. But yeah, so we'll put out a production curve. We'll put out confidence intervals, production drivers, analog wells, lots of different data sets. So some of our customers may care more about early time production. So let's say you're doing you're trying to design your offtake, or you're trying to get an accurate estimate of what your production is going to be for your quarterly budget and planning. That may be what you're most interested in. So you just want the rates for that. Other customers are maybe more interested in an optimization exercise. And so they'll want to go all the way out for 30, 50 years to get an EUR. But that's all stuff that we output. So it's all available for you there. Okay, what other questions? This has been great. Y'all been asking lots of questions. Okay, good. Ryan asked, how do the ML models handle features having a different percent contributions? Yeah, great question at each IP day time step. So 30, 60, 90. So Ryan, technically what we're doing is we're predicting a vector of production. So we're not predicting a single timestamp. You could predict like a 1 year cum or an EUR if you wanted, but we want, in order to get accurate economics and accurate shape of the curve, we'll predict a full time series. So you actually will see, and let me go ahead and pull this thing up here. I'm going to go into our blog here and show you something interesting. We actually will be predicting. So since we're predicting a time series, you may have slightly different feature importance at each time step. So I'm going to go ahead and pull up something that was in one of our papers that we put out at ERTEC a couple years ago, ERTEC 2020. So it'll be a common one to look at here. Okay. So this, we're actually looking at production drivers for proppant intensity in the Bakken across different time steps. So on the y-axis, you can see how much of an impact it has at a certain IP day. And basically, this is showing that the proppant intensity is having a much bigger impact at early time. It peaks in the Bakken at around day 120, and that falls to more like a 27% impact between like the largest and the smallest proppant intensity by the time that you get out to day 720. So yeah, that's all available as a time series. You can look at the Sharknado at different time steps. That's a very common workflow for our customers as well. So that's, yeah, great question. Okay, Xiang Ren asks, are users exposed to the training metrics or the software automatically picks the best model? So yeah, we will expose what the model has done in terms of picking features. The software will automatically do the hyperparameterization. So there are, if some of you are less familiar with data science, there are basically these things called model hyperparameters, and those will govern certain things like, we use tree-based models, so they build out these decision trees. So it might say how deep are the trees, how wide are the trees, how does it actually judge the accuracy? So there's a lot of different hyperparameters that can go into training a model. How big can the leaves be at the terminal nodes? And part of making an accurate machine learning model is investigating a wide range of hyperparameters to try and see which one is actually the most valuable to make the most accurate forecast. So that's something that we'll do automatically. But we're happy to, all that stuff is generated and captured in the back end. So we can always share that. If you're really interested, we can share that with you. Jorge asked, does the model throw out outliers? So for outliers, we do a couple things. One, we'll do cleanup within data engine. So we'll try and remove bad values there. And that can vary depending on what you're looking at. You can have incorrect values for training data. That can be proppant, fluid, production. So we can remove some of it there. And then the second is you can remove, you may even have valid data, but the well has some issues with it, like maybe the production allocation was bad, or there's an operational issue, somebody left the coiled tubing in the hole, something like that. But for those, you can go in, and I showed you the model inputs filter, and you can go in and set your thresholds for that. You should use some caution with that. It's not always, you can throw away a lot of wells that you had some issues with them, right? And you maybe get an inaccurate view of what the production is. So we definitely recommend a lot of caution. But the other thing is that we've chosen, we use mostly tree-based algorithms. It'll vary a little bit model to model. So those we will, by their nature, they're a little bit more resilient to noisy data than something like a neural network. That's one of the reasons that we've gone with it, gone with those algorithms, in addition to just their baseline accuracy, is that they're really quite well suited to oil and gas data, which is a little noisy. Okay, Ryan asked how long the models take to run. Like, how long would it take the example model that I set up? So most of our pre-drill models, I think I ran this one, it shouldn't be finished now, but most of our pre-drill models will take between 30 minutes and 12 hours to run, kind of depending on whether you use feature selection, the number of wells, and the number of features that you've used. Our post-drill models will take a little longer to run. Oh, sorry, allergies kicking in here in Austin. Our post-drill models will take a little while longer to run, and that's because we have a mix of different estimators, and we have more hyperparameter tuning than we do there, because we include featurized versions of the prior production for that. So those can take between 3 and 48 hours if you're doing a huge one. So that's about how long they run, and those will run all in the cloud. So there's no need for you to leave your desktop open or anything like that. And it's much faster than it would run if you were running it locally. So yeah, Connor says 30 minutes for that example. Connor's the one who's been building a lot of these demos recently. Thank you, Connor. So yeah, that's about how long it will take. So pretty fast for training one of these models, especially given the cross-validation, hyperparameterization, feature selection, all that type of stuff. The SHAP values take a long time to generate. So there's a lot of stuff going on behind the scenes. Okay, any last questions? As I mentioned, I'll send out a recording. This is also it was a quick whirlwind. We're happy to do a customized demo for you. So if you would like to learn more and speak with one of our experts, just send us a note. I put our email in there in the chat, intro@novilabs.com. If you want to get a more detailed demo, we can do it kind of customized to what you're interested in. So if you tell us, hey Ted, we're interested in doing appraisal in a new part of the field, or a lightly developed part of the field, we can kind of customize something to speak to that. So that we're happy to do that. And finally, Ryan asked, quick follow-up, is it running Chef by default too? Can you specify to include or exclude it to speed it up? It runs it by default. We probably will eventually give you the options to turn off some of those to speed up the model training. But right now we just kind of run it by default. So it's a great question. All right, everyone. Well, thank you very much for attending today. We'd love to hear your feedback. Please send it in to us. You can reach out to me. You can send us to an email. It's in our intro email. And there's my personal email as well. So feel free to send us your feedback, your thoughts, or if you have any questions that pop in as you're walking home from work or whatever, or on the drive home. If you're working from home, maybe you're not driving home. But yeah, let us know your thoughts, your questions, anything more like that. Yep, Jason dropped his email in the chat there as well. Jason's one of our managing directors. So thanks everyone. Have a good rest of your day.